Good morning, guys. Today our topic is hydraulic proportional control. Okay, controllers and control action also. So we have to know what is the action of the uh, proportional, integral, and derivative action. So first of all, we can understand through the transient graph. Okay, whenever a motor or a fan, you can see in induction motor, whenever it's getting start, then very initial point it will get some jerk. Means first it is from the static to the dynamic, then it will get some jerking. Okay, say our speed limit is this type of, okay, or power consumption is in this level. This is the static level and stability, but first time it will get some jerking. Okay, so this is called the transient. Okay, and this portion is called overshoot. Then it is gradually going to the lower side, then one by one, and then it is trying to reach the stability. After few times it will get stability, means then it became a steady. But this type of jerking is called the overshoot, and it is called transient. So from any static movement, static to the dynamic position, you get some jerk. You can see in your induction motor, first time it will take some high ampere. Okay, maybe it is the 5 to 10 ampere, and then after then it will coming to the steady state, and it will drawing only 1 to 2 ampere. Okay, as per the rating. So this whenever it will getting started, then it will directly going to the 0 to 5, and then it will come to the 1 or 2 ampere. Okay, so this portion is called also, it is the nature of a machine. As in whenever it will get start, due to why it is required, because due to from the very initial level to the higher level, and this is the static to dynamic. Static to dynamic, whenever will going to this, then it will get some jerk or get some overshoot or get some, it is called transient. Okay, but same things happens if there is a dynamic dynamic position is there, or it is a dynamic, then if you try to bring it into a static, then also it will get some thrust, but it will push, or you have to gradually stop this. Okay, but if you suddenly break this, just like your motor, just like your car, if you suddenly break this, then you get some force the opposite. This type of things are happens. But in your industry, in or say it is a something machine driven by your motor, so there is sometimes it is a rippling is there. You can see there is a lots of rippling after then, and it will get some static position. It will get the stability, and this is, you can see, this is, this action is working as a proportional. Say if there is the upper limit, it, say this is a 2 unit, then it will gradually closing, then it will uh, coming minus 1.5, so it is going zero point 0.5. After then it will getting zero point 0.1, then gradually it is decreasing. So here is some proportionality action is working. That's why this type of controller is called proportional controller. Actually, whenever this is one type of proportional action is working. So if there is the lower limit, it is going to the undershoot, it is going to the overshoot. If I put some damper over here, if I put some damper, or if I put some mechanism which will oppose this opposing this rippling, then what happens? If I apply proportional control over here, then gradually your machine will going to a stable condition very fast time, because we are using some obstacle, or we are using some proportional obstacle, so that it will reach the the stability. That is the action of the proportional controller, because in nature there is, it is a proportional action is working. So if I giving some opposition factor or obstacle factor, but this factor should be as per the action. If you static, if you put some static weight, so that it couldn't reach to the this position, then what happens is always uh, getting some negative factor is working, negative working is there. But it should be such a way, whenever it will going to the upper side, some proportion of this or some ratio will apply, where it will pull this graph so that it will come to the lower or get to the stability very fast. If it is going to the look, I am giving you the red line. If it is, if this graph or stability is going to the downward side, then it will put, it will pull to the upper side, so that it will get stability so fast. This is the action of proportional action. Now sometimes proportional action is so longer, so that it will get, it will try to reach stability, but within few seconds or few times. But we need a stable condition. Okay, we need a stable condition. Then we apply with this proportional factor. Say if I push this, or this pushing is called damping. Okay, here technically it is called damping. Say this overshoot is going over here. If some factor is push here, so that it will uh, get the stability very fast, then this action is called damping. Okay, so if I damp this overshoot, then what happens? It will just reach over here, and just you can see it will go in this way. Look, there is very less overshoot, very less overshoot. So if we, if we use some damping, as we know in this area the overshoot is occur very high. So integration action will be applied generally where the overshoot action is working. Okay, overshoot undershoot is working, so this will get, uh, it will reach the stability very fast. Okay, and now this is happens, p is always there. So the ripple factor or the proportionality factor will be damped by the integral action, so it is called pi. Okay, if there is, you can see, but this is our stability point. So we are applying some integration factor and p factor, but it is going to the, going to the near to the stability factor, stability line, but it will set point or the stability, but it will never reach the stability finally. So at that moment we are applying some derivative action. Derivative action means it will also working as a dam, but it will just hold it, means it will just break this area. Say this is just 1 millimeter here. If we apply derivative action over here, then what happens? It will become static over there. But you can see there is some gap is there. Okay, some dead zone is created. So this is the derivative factor, and this derivative factor is working as a brake line, or you can say this is used for the braking. Say in here it is also going, if you apply some derivative action over here, if you apply some derivative, say here is, it is locking, just lock it, never go, if it never go the upward side, it never go to the lower side, just become static. But it is not reach the, it will not reach the stability point. And evenly, if uh, it is, tuning is very difficult. If it is tuned at the set point, then it will lock over here. if anyone can set it, very difficult, but it anyone, if anyone set it, then it will just lock the set point value. Okay, so this is the proportional action, this is the P and I action, this is the Pi and D action. If we don't apply this I factor, say only we are apply P and D, so what happens? If we don't apply this I, then your, it must be your rippling is here, overshoot undershoot is coming over here, then it will going, and now in this area you are applying D, so here is only D. So this is the up to this is P and this is D. So this type of action is called P and D E control action. Okay, so guys, I think you can understand this thing, because such a motor, such a system in which are applying PID controller, they are getting the stability it is in this way. And whenever we are going for the electronics PID controller, then you can see how it is actually graphically you can understand these things. But in hydraulic proportional control action, uh, you can see some piston and spool valve action, so that it will get some proportional action. One another example is that in your music system you can use some knob, so that your sound may be controlled, maybe it is controlled or lower, maybe volume, sound volume. So this knob is a one type of variable resistance. Okay, or you may say this is the pot. This is the proportional control, how much you move this. If you move this, then sound will be high. If you move more, then this proportion is action. If you use the opposite movement, if you move the opposite movement, then it will reduce. If you move more, then it will all reduce, or sometimes it is going to the zero position. So this knob is also acting as a proportionality. This is also proportional controller. This is not controller, proportional control action also working for this sound system. So we are talking about how hydraulic proportional control are acting. So uh, yesterday you have seen some spool valve action. Okay, So remember this thing, and this is pump. Okay. And as usual, this is A and this is B, and this is your piston. Okay, so this is your power, and this is spool, and this is called pilot piston. On the spool valve is there. So guys, you can see in this position, P is connected with this A. P is, if you pull this valve over here, sorry, if you hold this valve, not after pulling, say its position was its position was in this position, say it was your previous position. Okay, it was your previous position. Now this is your original position. In this position, so you can see A is connected with this P and B is connected with only drain. Okay, so only because in this position this spool is covering this drain area, no fluid will connected with this drain, but here P is not connected with this B because this spool is just just covering this B position, and only B is connected with this drain. Okay, uh, so in this position what happens, only this fluid is coming over here, so fluid is coming over here, and this fluid, if this fluid is coming over here, so it will try to push this piston towards this area, so piston is going to this side, and as now it is just pushing this piston. Now piston in the position is, piston is coming over here, piston area is here is restricted. Okay, so from here it is coming up to this, so whenever it is coming up to this, then what happens, this fluid is try to drain out from this piston and it is going to the reservoir. So piston will be coming in this position, piston will coming moving and it will coming in this position, piston and will be coming in this position, and it will just coming here. Okay, okay, so this is this is how much you replace this treadle or this lever, that much it will be move. So this is a proportional. Say if you can see, if you move this spool, if you move this pilot or move this spool by this lever, say delta say delta x, and it will move the x amount. So this is the ratio. Okay, this is the ratio. Delta x is to x. It is the proportional. So this is the and whatever may be, it will be the constant. This is called proportional constant. Say if you push this 1 inch or 1 centimeter, then it will giving you the 100 centimeter displacement. So it is the ratio of 1 is to 100. If you put 2 centimeter displacement, then it will remove this much. So in this ratio, it is working. Okay. And now, what is the another action? How could we realize this another action? Okay, I'm giving you the another picture so you can understand this. Now it was in this position. In a previous position, it was, you can see your spool is in this position. So you can draw your spool. Okay, it was your previous position. So it is your pump, it is your drain, it is your drain, and this is A and this is B. Okay, so if I push this, means I put over here. So what happens? You can see your lever is coming in this side. As this lever is coming in this, it will pushing over here. So this position will coming over here. This will coming over here, and it will coming over here. Okay, so I am giving the bold line so that you can understand. You can understand this position. Okay, so what happens? It is coming over here. Now you can see, now A is connected. A is connected with this drain. This is drain. This is drain, and B is now connected with this B. So what happens? In previous section, it was empty and it was full. Now fluid is entering through this B. Fluid is entering through this B, and it will try to press this. Okay, your initial position is here. So whenever it push it, the your piston is coming. So your piston is coming in this side. Okay, your piston is coming in this side. So what happens? It will coming. I'm giving this in this area, so it will coming in this side. It will coming in this side, and your this piston will be removed. Okay. So now what happens? From this chamber of A, the fluid will trying to going to this out, and it is going to the drain. So in this way, your piston is working. So now your original position is here. Original position is here. You can see a small amount of displacement, it's create a large amount of displacement over here. In this way, we can just we can operate this piston. So this is the hydraulic controller, but this is a proportional controller. And if you put some angle or some displacement over here, then it will displace so many times. And if what happens, if I want to lock this position, because it is one by one, uh, as per that this timing is going on, say T1, say T22. So it is entering, fluid is entering, so it is increasing its pressure, because it is pumping, so it is entering its fluids. After some times, it is reached up to this position. It will reach up to this position if I hold this. Okay, but we want to control this. Means if this channel, you can see it is fully open, 100% open. But if it partially open, if it 50% open, then what happens? This movement is occurring in 50% delay. If it is opening 80%, sorry, it is at 20% open, then the movement is speed will be also the 20% speed, because it will not getting the original speed. And now if I want to hold this position, so what happens? So we pull this position, or such a position where it all lock this channel. Means here I am doing this red color. Say here this spool is coming here, and here also this spool is coming here. So what happens? You can see, if I am drawing with a new, then you can understand. Okay, look. uh, Say now your piston is, say your piston is in this position. Okay, in a abrupt manner in this position. Your spool is, your spool is just like this. So you want to hold this position, or you may want to break this position so that it will hold this position. But now you can see, this is A and this is B. B is connected with this pump and A is connected with this drain. Pump is always trying to induced fluid, inject fluid, but we have to stop this. So what happens? We have to select such a position so that this piston, this spool block both of this drain and this pump. So we have to push over here a certain point so that it come to this position. It will blocking both of this. So your previous position was changed. You can see this is your this is your present position, where you can see the B is not connected with, because pump, due to this pump it is not connected. It is not connected because B is covered by this block, by this spool, and A is also covered by this spool. So no fluid is going to outside and no fluid it can enter in this side. So what happens? It becomes static. It becomes static. This position is called alt braking, or this is a holding position. Holding position. So this I think you can understand the action of this hydraulic pump. So first it is connected such a position, and where A is connected to P and B is connected to drain. So whenever P is connected to A, then pump is try to inject the fluid it to the chamber of A, and this fluid where gathering over here, it create push on this pressure on this piston, and this piston easily going to the outside. But I change this position from this side to slightly this side. Then what happens? And this spool is, if I pull this action is happened. This is the lever, so it will pull this. So from this initial point, it was the your initial point. It was your initial point, and now it is coming to the here. So you can see this A is connected to this drain, and B is connected with this P. So now P is try to induce liquid or the fluid to the chamber of B. Then chamber of B getting exerts by this pressure, and it will create pressure on this piston. Then piston going to the inner side or the opposite side. In this way, if we change some very little position of this spool, it will enlarge or multiply or amplify this length. Okay, that's why it is called proportional. And how much proportional you do, and it will change this. And if I want to hold this, then we have to select such a position where both of this spool can cover all this A and B channel. Then it will holding. So that this is the proportional means, is if you put very little, it will amplify very high amount. That's why this is called the proportional. But you can see proportionality has no stability factor. If it is automatic, if if it is automatic, then it will live it then it will just amplify it, not to getting the stability. Okay, stability action is done by your manually operation. Okay, so this is your proportional action, and that's why it is called the proportional hydraulic control action. But all this time you need to work on this proportional action, because this is a basic, it's the base. Otherwise you can't apply this action is the proportional, and this is the basic. Okay, elementary, and then you can apply the integration, then you can apply derivative. But without this proportional action, total system became just stop. Okay, so this is the your uh, all about hydraulic proportional control action. So guys, if you have any question, then you may ask me. Otherwise, I just stop here for this day. Uh, guys, have you any question? Okay, thank you. I am going to stop here. Have a nice day.
Thank you, sir.
Thank you.